Over the past 15 years, Boeing planes have crashed or malfunctioned over 19 times, costing more than 1,300 lives. For an industry built on precision and trust, this is an unacceptable error rate. So how could such a top-tier company like Boeing allow these tragic failures to happen? We've spent 2 weeks uncovering the real causes behind these tragedies and found the shocking truths that expose a pattern. What we found will make you seriously think twice before boarding any Boeing plane anymore. Here's why. On January 5, 2024, an Alaska Airlines Boeing 737 MAX suffered a terrifying malfunction during its flight to Ontario, California. At 16,000 feet, the aircraft's door plug in the fuselage suddenly ripped off, causing rapid decompression in the plane. The force of air was so intense it reportedly tore a child's shirt off and slammed the locked cockpit door open. Miraculously, none of the 171 passengers or 6 crew members were seriously injured. But the real question is, how could the door plug detach so easily? Basically, the door plugs are specifically designed to stay securely fastened to the fuselage using locking bolts and guide tracks, even under extreme pressures of high-altitude flight. Yet in this case, something clearly went wrong. Investigators initially suspected that the fasteners either failed or were improperly installed. They pointed to 3 possible reasons. The bolts were improperly tightened, the wrong size or type of bolts were used, and some bolts were missing altogether. But the final investigation revealed something far worse. 4 bolts were missing from the door plug, leading to its mid-flight detachment.
PSB investigators say 4 bolts that hold the door plug in place on the Boeing 737 MAX 9 were missing at the time of last month's blowout on Alaska Airlines Flight 1282.
And the story doesn't end there. Just months later, on May 25, 2024, Boeing faced another major mechanical failure. This time, a Southwest Airlines Boeing 737-8 MAX on a flight from Phoenix to Oakland encountered a Dutch roll at 32,000 feet. To put it into perspective, a Dutch roll is a rare but serious issue where the aircraft simultaneously rocks and sways due to instability. According to the Federal Aviation Administration, the plane carried 175 passengers and 6 crew members, but thankfully, no injuries were reported. But again, this Dutch roll was caused by a damaged power control unit, which affected the plane's directional stability. What makes these incidents truly alarming is that both malfunctions were directly tied to Boeing's own manufacturing flaws. But, despite a catastrophic event in January 2024, Boeing failed to take decisive action, leaving critical safety improvements neglected. This negligence led to a second disaster, which could have easily been prevented. Basically, crashes in aviation are often the result of 4 primary factors: pilot error, mechanical failure, weather conditions, or sabotage. According to most researchers, over 60% of these incidents are linked to mistakes made by pilots, while around 22% stem from mechanical issues or technical errors. When a particular aircraft manufacturer or one of its models repeatedly encounters malfunctions, it points directly toward the mechanical and engineering flaws of that company, indicating deeper problems within the manufacturing process. With 2 significant aircraft malfunctions in the same year, public concern grew, leaving many questioning the overall quality and safety of Boeing's airplanes. But this wasn't an isolated issue. Boeing has faced such scrutiny over quality for years. Warnings about the declining standards of their aircraft have been circulating for a long time, yet they largely went overshadowed by Boeing's strong reputation and dominance in the aviation industry. Back in 2013, the 787 Dreamliner was greeted as the future of Boeing, expected to elevate the company back to its former glory. However, shortly after its debut, multiple incidents involving lithium-ion battery fires on various 787 aircraft started coming to front, raising serious safety concerns about the reliability of its cutting-edge technology. One notable incident involved a parked Japan Airlines 787 at Boston's Logan International Airport, where the lithium-ion battery caught fire shortly after passengers had landed. In another case, an all-Nippon Airways 787 flight was forced to make an emergency landing due to a battery malfunction. These events highlighted critical issues with the Dreamliner's battery systems and hinted at deeper engineering problems within Boeing's approach to incorporating new technologies. Chemical engineering professor Levi Thompson commented on the situation, explaining how overheating of batteries could have caused leaking fluids.
Most of the batteries that we put into devices, they've gone through a number of very stringent tests to try and ensure that for that application they're going to be safe. If you overcharge a battery, the chemicals inside can often change from liquid to gas. That gas creates additional pressure in the battery. Again, if those seals are not able to withstand that pressure, then something has to give. And once it gives, then all of that stuff that's inside is then exposed to air from the outside. And if there's an ignition source around, then you could generate a fire.
This testimony clearly indicated that the batteries used in the 787 Dreamliner should have been subjected to rigorous testing to account for the unique demands of aviation, but they didn't. As a result, aviation authorities worldwide grounded the entire 787 fleet, the first time in over 30 years that a commercial aircraft model had been grounded. These incidents reveal a disturbing pattern of how Boeing controls its production quality, and that pattern screams of clear neglect. Boeing has consistently prioritized production speed over essential safety checks, but these shortcuts haven't led to any benefits. Instead, they've caused a massive blow to Boeing's once sterling reputation. What's worse is that the full scale of this damage is yet to be fully understood, but you're about to uncover just how deep this crisis runs. In October 2018, Lion Air Flight 610 took off from Jakarta's Soekarno-Hatta International Airport on a routine domestic flight. Shortly after takeoff, the aircraft began to experience control issues. Despite the pilot's efforts to stabilize the plane, it entered an uncontrollable descent and crashed into the Java Sea. Tragically, all 189 people aboard. Just 5 months later, in March 2019, a similar disaster unfolded with Ethiopian Airlines Flight 302. Departing from Addis Ababa, the flight faced control difficulties soon after takeoff. The pilots made desperate attempts to regain control of the aircraft, but like Lion Air, the plane went into an uncontrollable descent and crashed into the town of Bishoftu, all 157 passengers and crew. They were both Boeing 737 MAX, and both crashes were traced back to a failure in the Maneuvering Characteristics Augmentation System, MCAS, which incorrectly activated and forced the plane's noses downward despite the pilot's efforts. Now, these incidents revealed two shocking questions that we could no longer ignore. Why did the MCAS system, designed to improve flight stability, suddenly malfunction in ways that led to disaster? And perhaps even more disturbingly, this entire fleet was certified as safe by the FAA. So how could this happen under their watch? The answers will leave you questioning the very foundation of Boeing's safety standards. The investigation reports revealed that Boeing failed to fully disclose the extent of MCAS's control and its ability to activate repeatedly without pilot input. Also, MCAS relied on data from a single sensor, making it vulnerable to malfunctions. Moreover, Boeing decided not to include detailed information about MCAS in the pilot training manuals. The reason was to avoid extensive retraining costs for airlines transitioning from the older 737 models to the new 737 MAX. Terrible, right? Now, the second question. How did the FAA overlook this flaw? Traditionally, the FAA was responsible for rigorously testing and certifying new aircraft before they could enter service. However, over the years, budget constraints and staffing shortages led to a shift in responsibility, creating a system where much of the certification process was delegated to the manufacturers themselves, a practice known as Organization Designation Authorization, ODA. This program allowed Boeing to conduct much of the safety testing in-house. In Boeing's case, this meant that the company was essentially allowed to certify its own aircraft with minimal oversight from the FAA. So, the FAA was unaware of the full scope of the issues with MCAS, leading to the system being approved without proper oversight. These revelations exposed a disgusting truth. The recurring mechanical errors with Boeing aircrafts were not mere technical malfunctions. Instead, they were the result of Boeing's relentless focus on profits, at the expense of rigorous engineering standards, directly contributing to the catastrophic failures that followed. The crisis shook Boeing to its core. placing Muhlenberg's leadership under intense scrutiny as the company faced global backlash. His neglect enraged the public, and the mounting pressure ultimately forced CEO Dennis Muhlenberg to step down. But this was all back in 2019. The new era of Boeing was supposed to start with Robert K. Kelly Ortberg, who became CEO of Boeing on August 8, 2024, and has worked hard to salvage the company's image and restore its position as an industry leader. With over 3 decades of experience in aerospace, Ortberg brought a reputation for turning companies around. Ortberg, in his first memo, quoted that, "While we certainly have a lot of work to do in restoring trust, I'm confident that working together, we will return the company to be the industry leader we all expect." However, despite Ortberg's efforts, Boeing's problems have not left the company alone. The Boeing Starliner mission in 2024, which was intended to be a pivotal moment for Boeing's space endeavors, faced significant setbacks. Initially, helium leaks, thruster malfunctions, and unsettling voices were detected as the Starliner approached the International Space Station, ISS, forcing astronauts on board to take manual control.
NASA has identified the source of a strange pulsating noise coming from a speaker in Boeing's troubled Starliner spacecraft, which has been docked at the International Space Station since June. NASA astronaut Butch Wilmore radioed Mission Control about the bizarre sound.
Yeah, I'll do it one more time, and I'll let y'all scratch your heads to see if you figure out what's going on. Here we go.
NASA says the noise turned out to be feedback from the communication system. Starliner is expected to return to Earth with no astronauts on board later this week.
Later, when Starliner's return to Earth was delayed due to ongoing mechanical issues, NASA eventually decided to bring the spacecraft back without astronauts on board, citing safety concerns during the mission. This was indeed another question mark on Boeing's quality control and engineering capabilities. Making matters worse, on August 24, 2024, NASA and Boeing held a press conference to explain the issues with the Starliner mission, but Boeing executives, including John Shannon and Mark Nappy, were unexpectedly absent from the picture. When questions about the absence were raised, NASA simply responded, "You'll have to ask them," fueling speculation about internal tensions. NASA's Commercial Crew Program Manager Steve Stitch later admitted that there was some tension in the room as the agency made the decision to return the Starliner spacecraft without its crew due to ongoing safety concerns. This indicates that this absence and Boeing's continued challenges with the Starliner program have strained the long-standing relationship between NASA and Boeing. We have devised that behind all the accidents involving Boeing aircraft lies a pattern of the company neglecting strict technical standards in favor of aggressive business goals. But here is the bigger question. If it's not the engineers at fault, who is really to blame for Boeing's decline? There's something far deeper at play here, embedded within the very way Boeing operates. In our next video, we're going to dive deeper into these issues to understand how Boeing reached this flawed approach, which is shaping its future. Thanks for watching. Make sure to like and subscribe.